All right, so we're looking at graphing quadratics. So I'm not really calling this a section number. I'm just going to call it graphing quadratics. Or we'll call it quadratic functions, because that's really what they are. Okay. All right, so we got different forms. You got your handout with you there that's got the standard form written there at the top, and we'll start with it, and then we'll do vertex form after that. So we'll start with standard form. All right, so there's a lot of things that we want to find when we go to graph a quadratic formula in standard form. Ax squared plus bx plus c. Important things that we're going to find are axis of symmetry, vertex, the x-intercepts, the y-intercept. Those things are very important parts of it. So we're going to find those, no matter what form we're in. Everything that's on this page is what we're going to find for each one of these. Okay, so it's a lot of information about each individual problem. But if you have all of these things, the last thing written there is the graph. If you've got all this other stuff, the graph, drawing the graph is super easy because you got everything else done. Okay, you got the hard part done. And kind of the way the quizzes and tests will work is there may be a few that you have to find all of this stuff for, and there will be a blank there that says, instead of having the formulas and stuff, it'll just be the same thing but with a blank beside it, for you to fill it in. So standard form is what we're going to start with. Y, or they may have f of x written. Same thing. Yeah, you grabbed some quadratics, but you didn't do all of these things. You did some of them, but you didn't do all of these. So there's a little bit more involved. So it is something you've done in Algebra 1, but a little bit more involved. Directrix, focus, I know you didn't do, but the rest of it you really have done before. Directrix and focus might be the only new thing. Yeah. I don't remember. Coach Max taught it several different ways. If you had him for Algebra 1, I've kind of taught it only one way. So I didn't do everything that's on this page. All right, so let's start with an example. Example A, we're going to get an equation that's in standard form. So I'm going to do number... No, I want to do number 10. This is number 10 from that handout. I'm doing number 10. I'm going to kind of go down in the middle of the page. Y equals x squared plus 6x plus 11. Okay, and I want to go down through the steps that are on this page of things to do. And I've kind of got a couple of things out of order here that I meant to swap before this semester, and I didn't do it. It's my fault, but we're going to find those pieces. So one of the key things that would help you here is if you list A, B, and C, since it's in standard form. This helps you when you use quadratic formula. If you were to do that, like some of you struggled a little bit with that. So if you would list A, B, and C, it probably would help you here. So A is 1, B is 6, and C is 11. All right. So first thing that we want to find is the axis of symmetry. Axis of symmetry. Okay. And an axis of symmetry, when you graph a quadratic, it's going to make this parabola shape. It kind of looks like that. The axis of symmetry is this imaginary line that goes through the middle, that if you folded the graph across that line, it would match up perfectly on both sides. That's the axis of symmetry. There is a formula for that. Right there on your sheet, it says x equals negative b divided by 2a. All right. So we're going to take the b and the a that we have in this equation and just calculate that. So that'd be negative 6 over 2 times 1, which equals negative 3. The axis of symmetry is this line, x equals negative 3. It'll be a dotted line when we draw the graph, but that's key, is having that number. Okay. The next thing that we would look at is the vertex. So the first thing you find is the axis of symmetry. The second thing you find is the vertex. The reason you do them in that order is because whatever this is for the axis of symmetry, that's the x value of the vertex every single time. Okay, if you look at the formula that I've got written there for vertex, it's an ordered pair. So we're looking at a point. The x value of that ordered pair is the negative b over 2a. That's the same number that the x-axis of symmetry is. So our vertex has the negative 3 in the x place. To find the y value, if you got an x value, to find the y value, you just plug it in. So we plug in negative 3 in the place of x in the problem. Okay. And work it out. So that would be 9 minus 18 plus 11 should be 2. Is that right? Check my math. The y value that goes with that x value of negative 3 is negative 3 positive 2. That's our vertex. And what that means is that's going to be the point that's either the highest on the graph or the lowest on the graph when you got a parabola. Now we need to decide, is that a maximum or minimum? Maximum or minimum, look at your cheat sheet here, is decided by what? What's it say over there? A. If A is greater than 0, that means A is what kind of number? Positive. If A is positive, then the vertex is going to be a minimum. Okay? So this is a minimum. Because the graph is going to open this way. If A is positive, it opens up. If A is negative, it opens down. And that decides the maximum or minimum. If A is positive, we have a minimum because it's got a lowest point at the bottom. If A is negative, it's going to open down, so we've got a highest point up here at the top. Okay, so we can decide those things. So this thing has a minimum, and then we can say it opens up. So we've clicked off 4 of those things already. Okay. 2 very important things: axis of symmetry and vertex. Axis of symmetry helps you find the vertex. Finding the vertex helps you find the next things, which is called the focus and the directrix. Okay. So this would be 3, 4, 5 is the focus. The focus is a point. Okay. I'm gonna put some notes here. This is a point. This is a point, meaning it's a dot on the coordinate plane. Okay, that's what I mean by a point. Okay, that means it's an ordered pair. The focus for a parabola that opens up and down is going to be related to the vertex. The thing that's going to change is the y value of the vertex. The formula there says take h and leave it alone. H is the x value of the vertex. I'm using h there because it was easier to type than negative b over 2a. H is the same thing. This is negative b over 2a. That's the same thing. This is coming from the vertex. The y value of the focus, you take the y value of the vertex. Y value of the vertex. And you add 1 over 4 times a to it. The formula that you want to commit to memory out of that. I would love it if they would give you these formulas on the end of course test or the ACT, but they do not. So this is some things that you're going to, as you're practicing this, you're going to try to memorize some of these formulas. And you do a few of them, you kind of get used to doing the same thing. Now, so for this one, our vertex is negative 3, 2, and we're going to add 1 over 4 times a to the 2. And we're going to work that out. So that'd be negative 3. So what's 2 plus 1/4? It's 2 and 1/4, or 9 over 4. Yeah, 9 over 4. So this is our focus. What the focus is, we know this graph is this kind of shape. The focus is this point inside of that. How many of you have a satellite dish at your house, like a DirecTV or dish? You know that dish is curved, right? And then there's this little bar that comes up, and there's these little round things on it. Those are not at random lengths away from the dish. They're at what would be the three-dimensional focus. Like the signal comes in from the satellite in outer space, bounces off the dish, and then into that little arm that's coming out on top of it. That's how your signal gets to your TV.
Yeah,
It doesn't get. Yeah, that's right. It doesn't get the signal from the direct satellite. Okay. So what's the focus is if I were to bounce the idea of it here, we're dealing with two-dimensional, like on a flat plane instead of 3D. So think about this as a satellite dish. This is kind of like a side view of it. If I bounced a signal in there, what happens, because that's the focus, is if I bounce something in there, it will automatically bounce down to the focus every time. Okay, so that's what it does. That's where that point is, and that's why it's special as far as a vertex go. As far as a parabola goes, and it's straight on line with the vertex. If you think about it coming from outer space, it's probably coming in more like this and bouncing up that way. That's more like the satellite dish is happening. That it's coming in and it bounces off the dish, and that dish is curved to a certain, the right mathematical way that it bounces that signal to, what are they called, LMBs? I don't know if anybody's dad or mom is a satellite installation person. I think they're called LMBs, and it bounces that signal straight to it. That's the focus of your satellite dish. We're talking about a focus of a parabola here. So a little bit more simplified version of that. But that's what that point is. It's inside of the parabola, and it's on the same line as the vertex. So it's on the axis of symmetry, but it's inside of there. Yes, sir? Well, kind of. Your TV at night is on a 3D world, so it's a little bit more difficult than this is. But this is a simplified version of that, yeah. So pretty neat thing for me, for us nerds to think about, or for me to think about. You probably don't think about this stuff, but I do. I always think about why does that work that way. All right, so whatever the y value of your vertex is, you're going to add 1 over 4a to get the focus. Okay, that's the focus. The next thing is the directrix. So this will be number 6, the directrix. And I probably don't pronounce it clear enough. It's a line. Okay, this is a line. Y equals k minus 1 over 4a. So all you've really got to remember is 1 over 4a and know that the focus is addition. The directrix is subtraction from the y value. It's the same formula, okay? So to get the directrix, and I'll show you what the directrix is. So here's your parabola. We got the focus inside of here. The directrix is this line on the outside that it's kind of the opposite of the focus in that whatever the distance from the focus to that point, it's the same distance down to that line is what happens there. That's what's going on. But we want to be able to find this equation. So we're going to take y equals 2 minus 1 over 4 times 1. So we're subtracting 1/4 from 2, which would be 1 3/4, 4, 7 over 4. Is that right? So the directrix is this equation, y equals 7 over 4. That's where that would be. Right? So we're getting all these pieces here to build a graph from. So we're going to draw all these things on a graph in just a little bit. Okay. So there's our directrix. So far we've done 6 things and not graphed it yet. Okay. The next thing is the discriminant. What's that related to? Where did it come from? Quadratic formula. That's absolutely right. What did we use the quadratic formula for? What were we doing when we solving quadratics? And what did it have to be equal to in order to 0? When we're setting a quadratic equal to 0, what we're really finding are x-intercepts. That's what we're finding. We just called it solving for the last week and a half. We're finding x-intercepts. We're finding where the thing crosses the x-axis, which relates it to the graph. All right. So what we want to be able to do, when are you going to find a discriminant? When the equation is in what form? What form are we dealing with here? Standard form. That's the only time you got to find a discriminant. Okay. So we're going to find the discriminant, and that's going to tell us if we even have x-intercepts or not. We may not. So 7 is the discriminant. B squared minus 4AC. So B was what? 6? 4 times A was 1, C was 11. So we end up with 36 minus 44, which is what kind of answer? Negative. Negative what? Negative 8. What does that mean about our answers in the quadratic formula? They're complex, which complex is not real. What this tells us is that little key there. It says how many x-intercepts. That right there in the middle of the page. If b squared minus 4ac is less than 0, what does it say? The very first line. No x-intercepts. So that means our graph should not cross the x-axis. Okay? So it's not going to have x-intercepts because this is negative. So this tells us there are no x-intercepts, which is great. That lets us skip a step. We know there are not any x-intercepts. We don't have to find them because you can't. All right? So number 8 says x-intercepts. We'll just say there's none. The next thing is y-intercepts. If something is on the y-axis, what's the x value? 0. Yeah, that's right. So to find the y-intercept, you plug a 0 in for x. And we should see something happening there. 11. So the y-intercept is at 0, 11. What is that 11? Where'd that come from? What part of the problem was it? A, B, or C? C. If it's in standard form, the y-intercept is always going to be C. Never anything else. If it's in standard form. Okay? And if you look at that handout, most of the ones on that handout are in standard form. So you're going to get y-intercepts almost for free all the time. Okay, if it's in standard form. All right, finally, number 10 is graph this thing. All right, so we're going to graph it on a piece of graph paper. So I'm going to draw myself a coordinate plane. And we're going to graph all of these pieces that we found. And try to do a pretty phenomenal job of graphing it. And then we'll graph it with a calculator just to verify that we did things correctly. Okay, and I'm going to show you some helpful hints with the graphing calculator. I forgot. Need one of these. You might want to get it because I'm going to show how to use it. All right, so we got these important pieces from our work. So I'm going to go back up here to the top. Axis of symmetry is the first thing we found. X equals -3. So if I graph that line, x equals -3, it would go through that point right there at -3. It's this dot. I'm going to draw it as a dotted line because it's really not part of the graph of the parabola, but it helps us to visualize the symmetry that a quadratic has. Okay. The next thing we found was the vertex. What was the ordered pair for the vertex? -3, 2. So I'm going to plot that point. -3, +2. That's that point right there. There's the vertex. Okay? And let's see. We want to create, look down there where it says graph. We want to create a table of values centered around the vertex. That's a very important part. So we're going to make a table of values right here. I'm going to put the vertex in the middle. Okay. And then I'm going to pick two x values to the left of -3. So I'm picking -4 and -5 because that's easy. And then I'm going to pick two x values to the right of -3. So that'd be -2 and -1. Now here's where the graphing calculator comes in to help us just calculate those, because this is arithmetic to plug those in and work them out. So just to make things easier, I'm going to help myself by using this calculator to help me. So I want to open that thing up. And you need to type in the equation into the y equals menu. And I'll show you how to do that. All right, so I'm hitting y equals. I've got a big polynomial that I've done this morning in there, so I'm going to clear that out. So if you've got anything in there, clear it out. If you have any plots that are darkened in here, you need to arrow up to them and press enter and turn them off. Okay. All right. Now, I'm going to type in that equation. X squared plus 6x. So the x is right here beside alpha. You just press that button, it gets you the x squared right there. And then plus 6x plus 11. Okay. Now, I want to look at the table for this and get it to calculate my values for me. Okay. So I'm going to hit second graph. And I'm going to type in the values from my table. So I have -5, -4. I'm going to go ahead and type in the -3, even though I know. Whoops. All right. So are we here? Have everybody got that typed in? All right. So y equals is what you hit to type that in. So it's the top left button. Okay. And then to get the x, you hit the button right beside the green one. It's got an X, the first thing that's on that button. And then you type squared, right down here, plus 6x. Oh, that'd be cool if that was touchscreen. Look. And then plus 11. What's going on? Oh. Get x. There was something squared plus 6x. All right. Everybody else good? All right. So we're all on the same page now. Okay. So once we get this typed in, we want to go to the table and have it allow us to type in the x values we want to use. Because that's going to change with every problem, because the vertex is going to be a different number for everybody, right? Or for each problem, usually. So let's set everybody's table to where you can type the x values, that it won't create them on its own. So to do that, you need to press second and then the window button. And you should end up at table setup. Everybody there? Table setup. Second window. Get you to table setup. Set the independent to ask. So just arrow down there to that part where it says independent. Move over here to ask and hit enter. Set the dependent to auto. Okay. Once you've done this one time, you don't have to do it again. It's always going to, it'll stay that way until you reset your calculator or something. All right. Everybody got that set? I don't want to run off and leave anybody because this is kind of handy. All right. So the next thing to do is we want to go to the table. So once I've typed in my equation, I hit y equals to get back here. Okay. Once I've typed my equation in, I hit second graph to go to this table. Second graph. And yours may have numbers typed in there. It may not have anything typed in there. And what you want to do is type in the 5 x values that we're using. I'm using -5, -4. The next one is -3, enter. -2, enter. -1, enter. And then I've got this extra one in here, but it really doesn't matter. Okay. Notice what's happening with the y values. They're symmetric. You got this vertex in the center at -3, 2. Then you've got these other points that match up going out away from the vertex. That should happen. Okay. So I'm going to plot those points on my grid. So let me get those numbers. 6, 3, 2. Okay. So I'm just filling in my table. 6, 3, 2, 3, 6. I'm going to plot these ordered pairs on the graph. -2, 3, -1, 6, and then -4, 3, -5, 6. All right. That really creates the parabola shape. It's not a V. It's kind of more rounded like that. So I'm just drawing that. Okay. If you had x-intercepts, and we'll do one in a minute that does have x-intercepts, okay, you could plot those, and that'll help you draw it as well. Okay, if you've got x-intercepts, then you've already got 2 of your points of the 5 that you need. Okay, you actually have 3 because you'll have the vertex as well. All right. Now, the next thing it says is plot the focus. What was the ordered pair for the focus? -3, 9/4. So I'm going to plot that point. So I'm going to do it in green there. -3, 9/4 is how much? Be 2 1/4, right? So I'm going to go up to 2 1/4, which is about right there. I'm just trying to show, my dot's a little big because I'm trying to get it where you can see it. But it's just barely above the vertex. Okay, it's just a dot. That's all the focus is. It's just a dot. Then we want to plot the directrix, which is a line. And you go to 1/4 below the vertex. Which is about right there. And you draw this dotted line horizontally. Got that. Okay. This is y equals, was it 7/4? That's what that line is. Y equals 7/4. That green dot on the inside is your focus. That's the -3, 9/4 is what that is. Okay. So we found the directrix, the focus. We've graphed this. We got the vertex right here. We've got the focus right there. All of those points. Okay. It says draw the axis of symmetry and the directrix. I've already drawn the axis of symmetry. That's the first thing I drew. And then directrix is the green line. Okay. Those are the things we want to do. It seems it's a lot to do for each problem, but if you follow it step by step, it isn't horrible to do. Let's look at another one. Let's try to get one that does something different. So I'm going to go back to my notebook paper, and we're going to do example B, and we're going to find all that stuff for it. All right. This is number 1. Y equals -x to the second minus 3. I'm going to list A, B, and C just because I think that helps. What's A? -1. What's B? 0. There's not a plain X in there, so B is 0 this time. And C would be -3. All right. So the axis of symmetry, and I'm just going to abbreviate here so we don't spend all day writing out words. X equals -b/2a, so that'd be 0/2 times -1, which is 0. So the axis of symmetry is at 0. x equals 0. The vertex would be at 0 what? What do I get if I plug a 0 in for x? -3. Because y equals 0 squared. And technically, there's a negative on that, but there's no such thing as -0. 0 minus 3 is -3. Okay. Vertex at 0, -3. Is that vertex a maximum or minimum? Why is it a maximum and not a minimum? What part of the equation tells us? A being what? A being negative tells us that that's a maximum. It means the graph opens down. So maximum opens down. Those things go together. Okay. Next thing is the focus. So 0, -3 plus 1 over 4 times A. Always addition with the focus. -3 plus a -1/4. Excuse me, -3 1/4. So 12, 13, -13 over 4. I'm just writing it as an improper fraction just because that's more accepted in an Algebra 2 and college algebra setting. Okay. Next thing is the directrix. Take the y value of the vertex and subtract 1 over 4a. So all you got to do is just simplify that. -3 minus a -1/4 be -2 3/4. Be -9 over 4. Is that right? Check myself. -3 minus -0.25. -11 over 4 because I can't do math in my head anymore. All right. That's an equation. That's a line, remember? Horizontal line at that value. Okay. The next thing to do would be your discriminant. Well, b is 0, so 0 squared minus 4 times -1 times -3, which is a -12, right? So do we have x-intercepts? No. So x-int's, none again. What's our y-intercept? 0, what? 0, -3. Happens to be the same one as our vertex on this one. Won't always be that. Just happens to be on this one. Okay, our y-intercept the same as our vertex on this one. Okay. Now we're ready to graph it. Got all this information, and let's graph it. This is example A. Go to example B. So coordinate plane. I know it's opening down and starts at -3. So I'm gonna put my, where is my axis of symmetry? It's x equals 0, so it's just right on top of the y-axis. That's where my axis of symmetry is. So I'm just trying to show that it's the same as the y-axis. Okay. The next point I plot is the vertex. 0, -3. I need to build my table of values around that. 0, -3. So I'm going to do -1, -2, +1, +2. And I'm going to use the calculator to help me, because it's, I'm just plugging in numbers. If you want to do it by hand, that's your prerogative. You are welcome to do that. I'm going to type in -2, -1, 0, 1, 2. I get -7, -4, and then -4, -7. I would plot those points. Oops. They match up on each side. So the parabola shape is there. My axis of symmetry is through the middle. I've got to plot the focus, which was at 0. What? Focus was at 0, -13/4, which would be -3 1/4. So it's not very far from the vertex. It's about right there. The directrix is on the outside of it, at the same distance. Okay. There's the directrix of this line. The other green dot is the focus of our graph. Depending on the values that you have, that focus and directrix can spread out a little bit depending on what the numbers are in the problem. It's usually going to be real close to it though, but not always 1/4 away. If A is different, it either gets closer or further away, depending on what A is. All right. Standard form. That's how we're doing it. Okay. All right, let's go to a problem that's in vertex form. And we're going to see that if it's in vertex form, we get a lot of stuff for free. Really, really easy calculations with vertex form that we don't have to do as much work as we do with standard form. So vertex form. Vertex form. Y equals A. That's the same A that it was in standard form. It's not changing. X minus H squared plus K. All right, we'll look at number 6 in just a minute. I want to do number 8 first. And then we'll do number 6 second. Okay. So vertex form, we're doing number 8 first. Example C. Y equals X minus 1 in parentheses squared plus 2. All right. We don't have an A, B, and C on this one. We only have A. What's A? What's in front of the parentheses? 1. There's nothing there, so it's a understood 1 in front of there. So A is a positive 1. What do we know about how this thing opens because A is a positive number? Which way is it open? Up. It opens like this. Okay? We know that's what's happening. All right? So we're going to find the same stuff. The reason they call it vertex form is because the vertex is right there for us. It's what HK is. And in this problem, H is 1 and K is 2. So our vertex is at 1, 2. And then the axis of symmetry, this is where you kind of flip-flop the order you do that in, is X equals 1. It's whatever X equals H is. X equals whatever H is from the vertex. Always. The X value of the vertex and the axis of symmetry should always be the same. Never different. Always the same. Okay. Then we need to decide, is that a maximum or minimum? Well, y'all said it opened up, so it would be a minimum. I have to be a minimum. So minimum opens up, or those things go together. All right. So after we find that, we want to find the focus. Focus. Same thing. Vertex, 1, and then we're taking 2 and adding 1 over 4 times A. 1 over 4 times A every time. 1 and 2 1/4, which would be 9 over 4. Directrix. Same thing. Y, and we're doing the K value of our vertex. What the Y value of our vertex? 2 minus 1 over 4A. 1 3/4, so that'd be 7 over 4. So there's our focus. There's our directrix. What about discriminant? Do we find the discriminant on this one? No, it's not in standard form. No need to find the discriminant. But that doesn't mean we get to skip the intercepts, if there are any. Okay? So to find x-intercepts, what do we do? What's it say to do to find x-intercepts? No. Set it equal to 0 and solve it. So we're going to set this problem, x minus 1 squared plus 2 equals 0, and solve it. We solved problems just like this last week. Solve it by square roots. We got something squared equal to a negative. So when I take the square root, what kind of answers does that get me? Complex. I comes out. So what does that mean about x-intercepts? If they're complex, do we have x-intercepts? No, they don't. There aren't any. Anytime that turns complex, when we were doing the standard form, we had the discriminant to tell us that. If it was negative, then it was complex, and that meant we didn't have x-intercepts. Here, we do the work to get there. It's the same amount of work. If you wanted to multiply this out to standard form and then do discriminant, you could. I don't know why you'd want to do that, because it's 2 steps, and you can decide if they're x-intercepts or not. And if they're x-intercepts, you're 1 step away from getting them. Anyway, okay. So there happens to not be any x-intercepts on this one. What about y-intercepts? Yeah, we plug a 0 in for x. 0 minus 1 squared plus 2. That'd be 1 plus 2 is 3. So the y-intercept is the point 0, 3. So we did have a y-intercept. No x-intercepts on this one. Now we're ready to graph that with all of that stuff. We know it opens up. Vertex at 1, 2. I'm going to make sure I got room in the positive. So my vertex was at 1, 2. Whoops. 2, 2. 1, 2. So the axis of symmetry goes through there. So there's my vertex right there, that blue dot in the middle. And then I'm going to make my table. I also know the y-intercept is at 0, 3. So I could go ahead and plot that point if I wanted to. If I have those, I can plot them, and it helps me draw my graph. Turns out, though, that when I do my table, I do 0, -1, and 2, 3 to get around the vertex there, I end up with that there. So I would go to my graphing calculator, and this is where I'd type in that equation, parentheses, x minus 1 squared, and then plus 2. And I'm going to go to my table and use -1, 0, 1, 2, 3. So 632, 632, 632. There, and right there. So there's my parabola. My focus was at 1, 2 1/4, so about right there. My directrix is 1/4 less than the vertex because my A was 1. And there I've drawn the graph of that. Okay. Again, the focus is inside of the vertex, above the vertex, or if it opens down, it'd be below the vertex on the inside. The dot. The directrix is this line on the outside of that. All right. Now, since we typed that equation into our calculator, we didn't hit graph a while ago, did we? I didn't show you that your calculator will graph it as well, just to verify that you got the picture looking close to the same. If you hit the graph button, not second graph, just regular hit graph, it'll draw that picture for you. It doesn't have the axis of symmetry drawn. It doesn't have the directrix drawn. It doesn't plot a dot on the vertex and all that stuff, but it draws that picture. So you can get a good idea. Did I do this right? Because if I didn't, then my graph won't look like this. Okay, so you can kind of check yourself by looking at that and make sure, hey, my graph looks something like that. That's pretty close to what mine looks like. And that's pretty close to what mine looks like. Pretty good. All right. All right. Let's do one more and then we'll be done for the day. And then tomorrow's work day, okay? So don't freak out thinking you're going to have lunch or homework. You're not. Let's do one more problem. Trevor, which one was it you wanted to do? 6. Let's do number 6 then. Number 6. You got y equals negative x minus 1 squared plus 3. That's number 6 on your handout there. So I've done 4 of the 20 problems. I'm going to leave you with 16 of them to do. Tomorrow. All right, go for it. You can stay as long as you want to. I'm leaving at 3:15. Okay. All right, so let's start with, what do we start with? Y'all tell me. A is what? What's A on this one? What's that tell us about the graph? It's opening down, that's right. All right, now, do we have a B and C on this? No, but we do have an H and a K, so maybe if you want to write those down, that'd be a good idea. What's H? 1 and K is 3. All right, so that tells us our vertex right off the bat, 1, 3. And it also tells us our axis of symmetry, which is what? X equals 1 or 3? 1. The x value of the vertex and the axis of symmetry are the same. Okay? And y'all told me that it opens which way? Down, which means the vertex is a what? A maximum, right? Because the original, the kind of the formula for vertex form is ax minus h plus k. It's always the opposite of what's inside the parentheses. That's why you can think about it. It's kind of like when we factored to solve, it always turned into the answer was the opposite thing. Same thing's happening here. It's the opposite of what's on the inside there. Very good question, because that's always a confusing part to this. All right, so we've got those things. What's next? Focus. How do we find the focus? All right, so we're going to add 1 over 4a to 3. and A is -1. So it's subtracting a fourth from 3, which is 2 3/4, which would be 11/4. So there's our focus. Next would be the directrix. They go together. Y equals K minus 1/4A. So here we have 13/4. The next thing is our intercepts. Let's get our x-intercepts. How do we find x-intercepts? Set it equal to 0. So we've got negative parentheses x minus 1 squared plus 3 is equal to 0. Got to be careful on this one, because when we go to solve that, it looks almost like that last one we did, but it's not. There's a -1 in front there. So now I have something squared equal to a positive number. So do I have x-intercepts now? Yeah, I got 2 of them. Okay, 2 x-intercepts here. And I got to find them. So I take the square roots of both sides, plus or minus on that side. X minus 1 equals plus or minus the square root of 3. So this is why we did all the solving before we started graphing, because we need these things. Okay, so let's get x by itself. So you add 1. So x equals 1 plus or minus the square root of 3. This is where we did the decimal approximation. That's why we did that. Is because when we're going to graph this, how many of you can tell me without a calculator where 1 plus the square root of 3 is? I can't do that. I'm pretty decent at math, and I can't do that. I can get close, but I can't tell you exactly. So we're going to get the decimal approximations now. 1 plus the square root of 3, 1 minus the square root of 3, and we're going to get decimal approximations for that. So 2 decimal places is probably plenty. So I'm doing 1 plus the square root of 3, 2.73, and then 1 minus the square root of 3. Negative 0.73. So my x-intercepts are at 2.730 and negative 0.730. What about a y-intercept? Yeah, sure. There you go. So how do we find a y-intercept? Well, yeah, put a 0 in the place of x. That's right. So y equals -1 parentheses 0 minus 1 squared plus 3. So it'd be -1 plus 3 is 2. The y-intercept at 0, 2. All right. Have I lost anybody on this part? I know it's a lot. Kind of heavy lifting today. What I like to call it. Doing some hefty work today. All right. You got all that stuff done. The next thing we need to do is build the graph. Number 6. Trevor picked a good one. So we got our table. We know we're going to build. And then, we're going to draw the coordinate plane. This. All right, so I got to have some information. I need to know where my vertex was. Is that 1, 3? 1, 3. Right there. And then my axis of symmetry obviously went straight through that, so I could go ahead and draw that if I wanted to. But it doesn't matter what order you draw all the stuff. You just got to make sure you got it all there. Okay, so there's my axis of symmetry and my vertex. it makes sense to draw those together because they're the same spot. You know, one's a vertical line right through the point. Okay. So my vertex was at 1, 3. So I need 0, -1, and then 2, 3. Well, I know what 0 is. It was 2, right? That was my y-intercept, wasn't it? 0, 2. So I got that point there. I'm going to put that in blue. 0, 2, not 0, 3. And then I bet you when I plug in 2 into the equation, I get the same thing. So I'm gonna go here and type in negative parentheses x minus 1 squared plus 3. Is that right? Yeah. And I'm gonna go to my table, and I'm just gonna build it the way that I did there. -1, 0, 1, 2, 3. I got the right x values already in there, so that's great. They just recalculated them for me. 0, 2. There's -1, -1. That'd be there. And then 2, 3, 2, 2. And then 3, -1, 3, -1. Now I can also plot my y-intercept or my x-intercepts. I plotted my y-intercept. My x-intercept, one of them is 2.73. So that's pretty close to 3. So there's my x-intercept about right there. That's a 2.730. That's what that point is. Notice it falls nicely into the line for the parabola. And then the other y-intercept or x-intercept was over here at -0.73, which would be about right there. That's -0.730. That's that point. Those are my x-intercepts. I'm labeling those because we hadn't had one of those yet. So instead of 5 points, I got 6 this time. And that's okay, but it makes my graph even more precise. And I could draw that parabola shape. Going out there. And let's get the focus plotted. The focus was at what? What was the focus? 1, 11 and 11 over 4. 1, 11 over 4 be about right there. And then 1, 13 over 4 would be about right there. So that's where my directrix line goes. Is up there. Now you asked me where you would use the directrix in your everyday life. I couldn't tell you one place that you'll ever use that. Oh, well, you shoot a gun, don't you? But that's the path it follows. It follows that path. We'll do some word problems here next week that talk about projectile motion, and they follow the parabolic path. Is what anything that's shot, thrown, kicked follows that path. Well, I wonder how military shoots miles away. Maybe you'll get better at it by learning how to do this. I know they got an app for that. Plug in the wind, yeah. How far the bullet's gonna drop? Yeah. All right. So handout 1 through 20. Again, we've already done 4 of them for you here. Be able to do all of these things for all those problems. Okay. So I would do all of these things for all those problems. And then our quiz will be all of these things for 1 or 2 problems, or maybe just 1 or 2 parts for several problems. Not sure yet. I hadn't made it out yet. So I'll know more tomorrow about how that's going to happen. Okay. So work day tomorrow. And then we'll practice this quite a bit here, guys. I know it's heavy lifting. It seems like